Explain why calcium chloride has a high melting point. To do this, you've got to identify the type of bonding present. 3 types of bonding: ionic, covalent, which can be broken into simple covalent and giant covalent, or simple molecular and giant covalent, and metallic. Okay, so what we've got here, to work out what type of bonding is present, we need to identify whether we have metals or non-metals in the compound we're given. To do that, you need a periodic table if you don't know it. Okay, so first off, calcium. Well, here's calcium on the periodic table on the left-hand side. Now, the metal-non-metal dividing line starts down here, in this group here, just the side of group 3, and then steps down. So calcium is very firmly all the way over here on the left of that line, so calcium is a metal. Chlorine over here, this is on the right-hand side, the metal-non-metal dividing line goes down here. Calcium is on the right-hand side, so that's a non-metal. So we've got a metal and a non-metal. Calcium is a metal, and chlorine is a non-metal. Metal and non-metal is ionic bonding. We've just got to learn that. So bonding is ionic bonding. Okay, so in ionic bonding, we have positive metal ions. So this will be made of calcium Ca2 plus ions and chloride ions, Cl minus ions. So in ionic bonding, we have literally billions of calcium ions and billions of chloride ions. And in ionic bonding, the oppositely charged ions are strongly attracted. So opposites attract. Strongly attracted. And held in, and we call it an ionic lattice. An ionic lattice is a regular arrangement of positive and negative ions all lined up. They're held strongly in place. Because they're held strongly in place, it takes a lot of energy to separate the ions. You're not breaking the bonds as such, you're separating the positive and negative attractions. Separate the ions, and that takes a lot of energy. All these questions and more on elshamhighchemistry.com.